Who else is here? Ashutosh. Okay, so I think with this, looking at the timing, we can get started. I'd
Sure.
like to introduce firstly Jatin, our guest, who's in Sydney at the moment, who's solution architect at OddZero. So OddZero is part of the Okta company. It's a subunit, and they represent the product called OAuth 2.0, if I pronounce it right. The talk today is going to be quite specific. So this is a good thing we have an expert. So Jatin is an architect on identity with 15 years experience in the field. So I think we're going to be well informed here. The topic of today is access tokens, being a key part of APIs. And there's a new OAuth 2.0 that specifies specific implementation details, different type of access tokens. So that's what we're going to cover here. So it's a pretty technical discussion, but I think we're going to be eased into it to just get a view of what the topic's about. So Jatin, so if you're ready, I see
Yeah.
you have your slides all set.
Yes.
You're going to be talking about the different types of API and access tokens.
Yeah. Yes.
So like I say, I mean, we have a few people on the call. There are going to be more people watching the recording. Could you give us a refresher, if you like, just maybe a slide on access tokens and their common uses? And then we
Yeah.
can dig down. Thank
Yeah.
you.
Definitely. So first of all, I mean, thanks, Jonathan, for my introduction. So I'd just like to start with just a very quick overview of OddZero. So at OddZero slash Okta, we provide the market-leading identity as a service, and basically we make life of for the developers simpler by providing an easy to use and easy to configure and extensible authentication and authorization service, so that they can then focus on their business logic rather than worrying about and spending too much time on authentication and authorization. And these are just a few statistics about OddZero, which is now an Okta company. Yeah, so with that, basically, let's move on to the sort of refresher that Jonathan was asking for. So here, so we'll be focusing on the types of access tokens uh, within OAuth 2.0. So as you probably may be knowing, like access token is one of the most fundamental or key pieces of OAuth, and basically the whole purpose of existence for OAuth is to enable a client application to receive an access token such that then it can use that access token to access a protected resource. And now that protected resource could be an API. So basically, access token is a very fundamental part of this whole OAuth puzzle. And these are just a few roles that the OAuth 2.0 specification talks about. Now, just quickly, the OAuth 2.0 RFC, right? It defines the access token as credentials, and these are something that a client application would use to access a protected resource, which is the API. So, and just a refresher on how exactly do we use an access token is that once the client application gets an access token, then it can use that in an HTTP header to access a resource server. So as you can see here, the client application has used the access token in the authorization header in order to access this particular protected resource. The resource will then validate the access token, and then if everything is fine with that access token, it can then return the API response. So simply put, this is the use of access token. So that was just a quick refresher before we jump on to the meat of the topic, which is different types of the tokens and everything. So this was just a quick refresher to get the ball rolling.
Okay. So it's basically a token is there to give access to a resource, right?
Yes, that is correct.
That's it. Then the devil is in the details.
Yes,
So I can see how many slides are there, right? Okay, let's split it up. So I guess the first question is, as you mentioned, what types of token?
yes. So Right. So I have prepared like a master diagram for depicting what are the different types of access tokens. And so so there are different classification keys that I put together, like depending on the format of the access token, or depending on what is the subject of the token, how many audiences does the token carry, is the token constrained to a particular application only that can use that particular token. So depending on that, there are all these several types of tokens. So for example, if we want to talk about token format, then in that case there are two types of access tokens primarily. So opaque tokens. Opaque means it's just a string of alphanumeric or hexadecimal whatever characters. It's a black box. It's a string of characters which does not make any sense to anyone other than the authorization server itself, which has issued the token in the first place. So an opaque token. Then the other one is the self-contained token, which is typically of the format JWT. Probably our viewers may be familiar with this particular format. It's called the JSON Web Token format, and it's pretty popular among developers. So a self-contained token. So when a resource server receives a self-contained token, it can easily look inside that token to see what exactly does the token point to. Whereas in the opaque token, there is no such possibility because it's an opaque token. So it has to reach out to the authorization server in order to find out like what exactly does the token imply and what information does the token point to. So that is a little bit about token format. Now, then coming to the token subject. So every token, every access token will have a particular subject that it is bound to. Now, depending on whether that subject is an end user or a service, we can call it as a user access token or a machine-to-machine access token. So a machine-to-machine access token is one that is used by one service to access another service. So it's like a machine to machine kind of a communication that is going on in the background. Whereas a user access token is used by the client application to access the protected resource on behalf of the end user. So this is the key difference between these two different types of access tokens here. Like one is the user and the M2M. So far we talked about the token format and the token subject. Now, another key aspect of the type of access token is whether it is constrained to a particular client application. And by sender here, I mean the client application, because the client application is the one which actually sends that access token to the resource server in order to access it. So basically, there are two types here, which is where the sender constraint is not enforced or enforced. So the not enforced is actually the default one, which is a bearer token. So bearer token really is comparable to a currency note. So you find a currency note, it doesn't matter who that currency note belongs to. As long as you go to the shop with that currency note, you can easily buy groceries or whatever. Like nobody is going to challenge you, like, oh, show me your ID and all that. Whereas if you enforce a sender constraint, then that means a particular token is bound to only a particular sender. So for example, just continuing with our example of currency node, so I can compare that with a traveler's check. So if you find a traveler's check, it is highly possible that you may not be able to encash the traveler's check, because in order to encash the traveler's check, there are a few items that are checked by the authorized party. Like for example, is it properly signed, and they may ask you to show your ID and all that. So traveler's check is very different from a currency note. So basically, when you enforce the sender constraint, not any application is able to use that access token. So if that access token gets leaked somehow, even in that case, it is kind of protected with this particular constraint, and thereby certain attacks, kind of impersonation attack and token replay attacks, they could be avoided using this sender constrained access tokens.
So is this the key way to prevent misuse of tokens?
That is correct. That's a very correct statement there, Jonathan. Yes, that's definitely a way to prevent the misuse of tokens. And the main areas like where I've seen this type of token adding extra security being used is like fintech kind of industry where with the open banking, open finance APIs that are getting more and more popular, which are like driven by several regulations in the market right now. So because the stakes over there are pretty high, like we are dealing with the people's money and finance and everything, so that's the reason why like the access tokens also need to be pumped up to a different level, which is the sender constrained access tokens. And another,
You were mentioning. Sorry, you said you have another security mechanism.
just another example of the industry where the sender constraint tokens is used is possibly like government or citizen identity kind of specifications or initiatives. Like, so since most of our viewers from Singapore, I can say that like SingPass or MyInfo are the two such specifications you may be aware of, which are like citizen identity kind of specifications. So they both also use sender constrained tokens in some form or capacity.
So that's great summary on how to prevent misuse. You mentioned earlier, just before this, about access to multiple resources through the same access token.
Yes. So yeah, I mean that's a good point there. So on the top left corner of my diagram, so you can see like one type of access token I've classified based on the number of audiences. So audience here just means the number of APIs that can be used to access that can be used by that particular access token. So basically, it could have either a single audience or multiple audiences. So if the access token has like multiple audiences, that means that same access token I should be able to use across multiple different APIs. Whereas if it's a single audience, I can call only a single API or a group of logical API, only single one, using that particular access token. So yeah, that's a good question there.
And then the last bit. So the last bit would be, I think, in the bottom left corner. What I'll do is, I'll depending on what you want to do, is we can go into more detail on this. So I would open it up to the floor. If people have any specific areas they want to dig into, yeah. Did you want to talk about? Have you already talked about the token subject?
Yeah, the token subject I referred to briefly. So basically, provided so every access token is bound to a particular subject. Now, if that subject is an end user, like an actual human being user, then in that case, we typically would call that as a user access token. So that access token can be used by the client application to access the protected resource on behalf of the user. Like, for example, your typical scenario where you would like to import your Google contacts on LinkedIn, or like those kind of scenarios where an actual end user is required. And the other one is the machine to machine token, where one service is simply communicating with the API, so there is no user identity involved in this particular scenario.
Yeah, could imagine IoT would be using this, or is it?
Yeah, I mean IoT definitely is a particular scenario where we could use M2M tokens. Although IoT, I mean I have seen use of both, like user access tokens as well as M2M. So yeah.
Yeah, security is not so great on IoT. Yeah, so just it may be too early. If anyone has got any specific requests on any of these topics, pop it in the chat. We did have one earlier question, right?
Mhm.
We could do the question at the end. Is I think you flashed up 9,000 users or something.
Like this one?
9,000 plus customers. So it doesn't seem. So what's the comment here? The comment was, how come only 9,000 customers? Right, there must be a lot more people using this.
Oh well, this one actually does not mean the number of users. Well, the users certainly are in millions, these are like 9,000 brands we are talking about, like 9,000
Brands, yeah.
plus 9,000 plus brands. And this slide may be a little bit outdated, so I'm sure the number is now more than 10,000.
Yeah, and this being open source, so I mean, there are going to be some people who pay for the services, some people who use it open source, I guess. So.
Yeah, it's not exactly like open source, but we do have like free tenants that developers can use, as long as so we have free as well as enterprise subscriptions. So yeah.
Right. So thanks for that overview. I wonder where to take it now. I don't see any sort of specific requests. So how would you develop this topic, right? We've looked at the summary. We've got about, I don't know how much time left, 10 minutes, 13 minutes.
Yeah, no worries. So basically, so we saw essentially like how we use an access token. So the client calling the resource server using that access token. So now going a little bit like just one step deeper into the different types of access tokens. So now opaque versus self-contained access tokens, right? So what exactly is going on here? What happens when a particular client uses a bearer token versus a self-contained token? So now let's say, an opaque token versus a self-contained token. So like over here, the client is using the access token as usual. Now, if let's say this token is an opaque token, right? Opaque token just means a string of characters. So I can just show you an example here. So this is an example of an opaque token. Just by looking at it, you're not able to gather much information. All this information that this particular opaque token points to is stored on the server side into this particular token cache. But just by looking at the token, you hardly are able to interpret any information whatsoever. So that's the reason why when a resource server receives that kind of an opaque access token, it has to rely on an authorization server, like the introspection endpoint specifically on the authorization server. So it just reaches out to the authorization server with that particular opaque access token. Then the introspection endpoint then fetches all the metadata that is associated with that particular token, and then it comes back to the resource server with all the information that is associated with the particular access token. And then that information helps the resource server, which is the API, to make an access decision, whether to allow or deny access to this particular client. Now, if it was a self-contained token, then that means, as you can see, like the resource server over here does not need to reach out to the introspection endpoint anymore. Like, so number 2 is not there anymore over here, because since it's a JWT, it can just simply verify the signature, it can consume the token claims, and then it can make the access decisions all by itself. So that's why we call it like, the self-contained token, because all information is contained within the token itself. There is no need to reach out to an external entity. So the self-contained approach is more scalable, as you can imagine, because there is no need for the resource server to reach out to the introspection endpoint every time. So it's definitely much more scalable. One advantage I can think of the opaque token approach is that just by looking at the token, there is no information that is leaked. Whereas in a self-contained token, by design, since the information is all encoded within the token, there is a lot of information that is available to the attacker if the token gets leaked. But anyway, like both of them are bearer tokens.
I mean, which came first? Was it JWT type, the self-contained one, or the opaque one?
Yeah, so the opaque ones, they definitely came first, and soon after that, most of the commercial identity as a service or OAuth authorization servers like OddZero, Okta, probably Ping, and all the other, they all came up with JWT based access tokens because of the scalability issues with the opaque tokens. So they all came up with JWT based access tokens. The OAuth specification, though, does not prescribe any particular format for the access token. It's all it just says, okay, it's a string, that's it. So yeah, I mean, it's by design, the OAuth specification is under specified on what format an access token should be.
I have some questions in the chat. related to this. Can you see them?
Yeah. So Celeste says, what's the difference between token-based versus cookie-based authentication? Uh, so, um, so the main difference between token-based versus cookie-based authentication is that basically cookie-based authentication relies on domain, like it cannot work cross-domain because your browser is not going to attach a session cookie or an authentication cookie to a cross-domain request. So cookie by design is attached only to requests from the same domain, whereas token-based authentication is can be used to access like a cross-domain resource. So that is basically like the main difference. Cookie-based authentication typically was used in days where most of your your application as well as your authentication service, everything they relied on the same within the same domain, or at least the same effective top level domain, so that you could use cookies at that in that kind of an infrastructure or that kind of an environment. But with all the modern distributed systems where you're using services like OddZero and Okta and all that, those are like cloud-based services, not hosted within your infrastructure. So so that's where token-based authentication, cross-domain authentication, and all that comes into picture.
I mean, would you say cookie is really local host?
Not exactly local host, but basically for example, if I have cookie for accounts.google.com, for example, then the browser is not going to send that cookie if I wish to authenticate to let's say www.example.com. So that's like a cross-domain request. Whereas if I have a cookie for account.google.com and I need to log into let's say identity.google.com, then in that case, browser would attach the cookie to that particular request, since it's the same domain request, and thereby we can achieve authentication or single sign-on because it's the same domain. Whereas cross-domain, really, the cookie is not an option. So I hope I answered that one. Now, should I move to the next one, Jonathan?
Well, looking at the timing, there's 7 minutes. How do you feel this one will be addressed now versus if you have anything else to cover?
Yeah, sure. So let's address that a little bit later. So now, just looking at how exactly do the token types look like. So this is an opaque token. Just an example of an opaque token, like I showed to you before. Now this one is an example of a JWT. So basically, on the left-hand side here in this particular image, that's the whole token. That's an actual token issued by OddZero, but it's expired and it's not. So you won't be able to use that token anymore. But anyway, so and on the right-hand side is the decoded version of the token. So since this token is self-contained, as you can see, it all points to all the information that is encoded by the token, like who is the issuer, who is the subject of the token, who is the audience, when exactly was it issued, when does it expire, who is the authorized party, what are the scopes that are contained within the token. All this information is encoded within the token itself. So the resource server, which is the API, basically, can just look up all this information for itself. Once it validates the signature, then it can easily consume all the information from this token. And thereby, it can then arrive at an access decision, whether to permit or deny this particular access. And then I'll be sharing this slide deck with the organizers. So I have some useful links and all that here. So feel free to visit those links. Then the next thing I just wanted to show you was, you remember the one of the criterias on classifying the access token was the sender constraint, whether we are going to enforce the sender constraint or not. That means, are we going to bind the token to a particular application or not? So there are two phases for that. Basically, one is the access token binding phase, and then is the binding verification phase. So if I start with this one, so an access token request, which should include like a cryptographic proof of possession, which means the client must somehow prove that, hey, I am in possession of a particular private key. And how it does that and all that, that is like really out of scope for this session because it's a bit involved and it depends on the specification that we are using. So then the authorization server that validates the proof of possession, and then the access token that is issued to this particular client application is bound to that particular private key. So thereby now the client application has a sender constrained access token, which is valid only for that client. It is not a bearer token anymore. So now in order to use that sender constrained access token, it just does a regular HTTPS request in order to access this particular API or an API gateway. And then over there, it also includes another cryptographic proof of possession. So on the resource server, it does two things. One is to verify the cryptographic proof of possession, and then it also verifies that the access token is bound to this particular client by verifying the token binding as well. And then if both of these checks succeed, then it moves on to verify and consume the token claims and make the access decision. If either of these fails, then it will send an authorization error that either the sender is invalid or the token itself is invalid. So that's where the sender constrained access token add that extra needed layer of security by not allowing a bearer token, but actually conforming the identity of the token itself, whether it is bound to a particular client or not. And yeah, and so like I said, feel free to, when you have access to this deck, feel free to go over these comparison and contrast for these particular specifications that are there for sender constrained tokens like mutual auth TLS, and this one is the demonstrable proof of possession and token binding. So if you're interested, I have also mentioned the links to the specific internet drafts, and I've kind of tried to compare and contrast these three specifications so as to get a good idea of when to use which one.
Actually, Jatin, we've got only a couple of minutes left. I notice Abdul has another question here. We've got to get to this first one, and this is related to tampering and security and transmission. Maybe this is appropriate.
Yes, sure. So Abdul is asking, what is the best token type or format to use to secure a connection between two web services that communicate over the public internet? So if it's like a service to service communication, not on behalf of any particular end user, then you would use the machine to machine access token. And in case so the simplest possible solution would be to use the machine to machine access token over a TLS channel. So that would probably be the simplest. Because even though they are communicating over public internet, still that communication channel is secured using TLS. So that's probably the default way to do that. But then depending on the security appetite of the two, or the risk profile for the two services, we could consider using one of the sender constrained tokens as well, provided the authorization server that you are using, it supports the sender constrained tokens. Okay, then the next question from Abdul is how to ensure requests received and proxied by API gateway have not been tampered during transmission from API gateway to the backend. Do we need a second token between the gateway and the backend, or we can use the same token coming from the API client? Yeah, so this is a very good question. Basically, so I mean, I refer to this kind of scenario as like a trusted subsystem. So whenever an authorization server issues a particular access token and the client uses that access token to communicate with a particular API, then let's say that request goes through the API gateway in your scenario. So the API gateway then validates the access token either using introspection or a self-contained token. And once that happens, then basically at that point of time, the request is now within a trusted subsystem. So a couple of options are the API gateway could probably not propagate the token anymore. The API gateway can proxy the request to the API backend using certain HTTP headers. Like, for example, it can relay or propagate the user identity information to the API backend using an HTTP header that, hey, this is the user, and hey, these are the user groups or whatever. So I've seen that pattern being used a lot, so that makes the life of the API backend much simpler. So that now the API backend need not be worried about the access token format and et cetera, et cetera. It can just rely on the information that is coming from a trusted source, in this case, the API gateway, and just consume the HTTP headers, and then that's it. So, but then again, of course, depends. Like if you want to use the token, then in that case, it can propagate the same token, or there is a token exchange specification where, the API gateway can then get another token and then, pass on that token to the API backend and all that. So yeah, there are several solutions to that, but probably the most common one I've used is the one that I said initially, which is to consume the token at the API gateway layer and then translate all the token information into HTTP headers and then relay that to the API backend.
Cool. We're actually at the top of the session now, so it goes very quickly. So recognizing people might want to jump off, we can continue here for a few more minutes. I'd like to thank Jatin. You got a lot of information here, so we need to get this to everyone. So we'll do that. The other thing is, are there any other ways that people could contact you? You've been talking about maybe design patterns already in response to these questions. How would people interact with yourself or OAuth?
Or OddZero, yes. For OddZero, basically, I mean, if you want to contact me, you can reach me via LinkedIn. I'm not that much active on any other social media, but you can easily find my profile on LinkedIn. Just search for my name and followed by OddZero maybe, and then probably the first profile you'll see is mine. So you can contact me over there, and in case you want to reach out regarding any questions regarding OddZero, you can find you can just Google search for OddZero developer community or user community, or user forum, and we have a developer forum which is pretty popular, so you can just submit your questions there. And in case you wish to meet with sales and all that, you can get some pointers over there or on the OddZero.com website.
Okay, so I'm just looking on Google, so hopefully I can find the right place. There seems to be community.
Yeah, so let me just open that here.
Would you rather do that, or I don't want to put the wrong link?
Yeah, sure.
So thanks everyone for attending this and participating. I think we've got probably a couple of minutes before we're closed off on this. But anyway, I'll conclude the session now. And if you have any other links to update Jatin on the chat will be open for longer.
Yep. Okay, sure. I'll update those.
So thanks very much, Jatin. Thanks everyone, and have a good day. Okay,
Thank
bye.
you. Yeah, bye.
Bye.